Okay, so today we're going to pick up with the same kind of chemistry we've been doing. But look at a new reaction called the Claisen Ester condensation, fancy name for something that's very, very simple. Okay? So let's take a look at this. What we're going to do here is react two esters this time, okay, instead of a ketone or aldehyde, where we did aldols last time. And we're going to react with base. And see what we get out of this reaction, okay? So let me draw the product, and then we'll see how we get there.
Let's see.
Okay, so here is the product where these two come together in this way. Okay? So let's take a look at the mechanism so we can see what's going on. So let's draw one of these esters. And react with base. Okay. Notice we're using a little stronger base than OH minus because these hydrogens are a little less acidic than on ketones and aldehydes. Okay. But the same reaction occurs. Take the alpha hydrogen to form the enolate. Question?
You don't have the A sodium?
Not here. If you recall, this thing together acts like this. So you can just forget it.
Okay.
Just forget it. Okay. So here we get our enolate. All right. And again, you should be able to draw the resonance for the other one. But remember, we use this one because this carbon is the nucleophilic carbon. So now we'll react that with our second ester. And where do you think that carbon will attack?
The carbonyl.
The carbonyl. So let's draw it attacking there. And this time we have something new, which is very nice for us. That comes in and it kicks the OCH3 off. So we have a leaving group this time. so that gives us our products. Okay, this is actually an easier reaction than the aldol to jump the full round with that OH that formed, if you remember that. Okay, so this comes in, kicks it off, and we have it added on. Any questions on it? Okay, so now I'm going to give you a few to do and see if you can work these out. Okay, does everybody have that?
No.
All right, so let me draw these up here. Okay, so let's tackle these two. Yeah. Yeah, we haven't quite covered that yet. Good challenge there. Like an oxo ester.
I have a question. When we see these, like somewhere, will it say 2 in front of?
I'm sorry. Okay, but the answer is yes. All right, so let's see if we can work those out. Feel free to pair up if you need some help there.
Just have to draw the zone. Now, then CH should be on that carbon. Good. Great.
I don't know what it's gonna take. Yeah, that's what I'm saying. I don't have to do all these. I'm just looking at the
Did you get it, George? Okay, who wants to come up and draw the first structure? Come on up. Thank you.
We don't.
Okay, does that look right?
I got it. I just, put the little thing. Okay, I just put, doesn't matter if we put it right here, cause I didn't put mine down there, I put it right here. Is that wrong? Okay, so, okay, so she had drawing. And I just connected it like that. That's what I did.
Any other questions on that? That is correct. Okay. Who wants to do the second one? Anybody get that far yet? Still working on it?
Yeah, but.
You got it, George? Let me check. All right. Good job, George. All right. Okay, good. Okay, so this carbon here attacked the carbonyl of the other and kicked off its OCH, its ethyl ethoxy group. Any questions on that? Okay, so that's the Claisen ester condensation. Okay, let's look at another one. This is a type of the Claisen.
Yeah.
And this is what's called the Dicarbonyl. Which is a cyclic Claisen condensation. Okay, so let's take a look at a setup of this. How would something like this work? Okay, maybe you can picture it here. That's right, it'll be the exact same way. So if you note, I highlighted one of the alpha carbons, this one here. Okay, so let's go ahead and address that one. So the base will take off one of these alpha hydrogens. I can do it nicely with an eraser. So that carbon becomes the enolate, okay? And now we'll have that one attack this carbonyl and kick that off, okay? So if you count the carbons, 1, 2, 3, 4, 5. So I'll get a 5-membered ring here with this carbonyl. All right? So let's draw that. There are the 5 carbons. Here, let me help you, CH. So let's make that the CH here. And that will be bonded to that carbonyl there. Like that. But yet that CH also has this ester group. To give us that product there. Okay, so that's the Dicarbonyl reaction, where we have 2 ester groups in the same molecule. Gives us a cyclic. Okay. So now let me give you some ones. See if you can work them out. products for that one. Those two.
We don't have to draw the mechanism.
If you want to. Maybe that'll help you find the product, but you don't have to. Just a little tricky to draw, but. Anybody get the first one yet?
Yeah.
Come on up. Anybody agree with that one?
No.
Anybody disagree? Okay. Pink, come up and tell us why you disagree.
Gonna draw what I got.
That's fine. Draw below it. Okay. Can you see what she's drawing on the camera?
Not all, it's cut off just a little.
Okay.
You want me to scoot it over some?
All right.
Yeah, scoot it over. Thank you. Okay, anybody agree with that one then? That's better, yeah. Okay, so you get the 6 membered ring. Okay, you probably just miscounted the carbons. Okay, so 1, 2, 3, 4, 5, and 6. Okay. All right, that's okay, you're allowed to make mistakes in here. Okay. Does anybody want to try this one here? Come on up, look. Don't be bashful.
Can you check when I'm first?
We'll check it after you draw it.
Okay.
Anybody agree with that one?
No.
Got one. You just, come on up if you disagree, draw me your structure.
Does it? You don't matter.
No, it doesn't. Draw it below. Okay, so you have a 5-member ring. Anybody agree with that one? Anybody disagree? Any disagreement at all? What about you, Blue? Do you agree?
I agree with the second one.
All right.
Why does the C double bond, why is it?
So let's figure it out here. Okay, so this one, 1, 2, 3, 4, and 5. Good. So 5-membered ring, attach that carbonyl, so there's the carbonyl, and this thing here is sticking off.
So I was missing
You're missing the carbon.
Dr. Neal, can you count the carbon in for the 5-member ring?
1, 2, 3, 4, 5. Okay, so that's falling into this one. Okay, so here, this lone pair is attacking there, kicking that out.
So which one's right?
Okay, so that's the decommit reaction.
The second one.
Okay.
Yeah. The one with the.
All right, well, let's shift our attention now to something a little new. We'll just get introduced to it, then address it more on Monday. Okay, here is the chemistry of what are called beta dicarbonyl compounds. Can you see that on the camera?
Yep.
Okay. All right, so what is a beta dicarbonyl compound? It is this kind of structure here. Okay, where you have an alpha carbon between the carbonyls, but what's the relationship of the carbonyls? They are beta to each other. Okay, so we get a beta dicarbonyl. Okay. No big deal with the name. The key is that you have a CH2 between two carbonyls. So if we take base to get this enolate ion, we get this here. Okay. So if you look, my enolate ion can resonance stabilize this way and resonance stabilize this way. Okay? So here we have two-way resonance. so that makes an extra stable enolate ion. Okay. So what does that say about the acidity of these alpha hydrogens? They'll be extra acidic. Okay, and we're looking at pKa values around 13. Okay? If you remember, for ketones and aldehydes that just had one carbonyl, this value was around 20 or 24. Okay, so we've come down a lot through this extra resonance here. Okay? So this is a key thing to take away. These are more acidic than the normal ones. Okay? So what we want to do is some chemistry on these types of molecules. Okay? And there's two different reactions we're going to look at for these compounds. Okay, the first reaction is what's called the Malonic Ester synthesis. Okay, fancy words. What does that mean? Okay. Here what we're going to have is a molecule like this. Okay? So if you look, we have a di-ester, okay? And we have that CH2 between two carbonyls. So this is a beta dicarbonyl compound, okay? And what we want to do, let's react it with base. Okay. So if we react with base, we get our enolate ion. And then what we're going to do with this is we're going to alkylate the enolate ion. Okay. So this will attack the CH3, kick off the bromine. To give us that. And then here's going to be the new step for us. Okay? We're going to take this and react with H3O plus and heat. Okay? And we'll go over this more on Monday, but let me tell you quickly what happens. Okay? We're going to take one of the ester groups and get it the heck out of there. Throw it off. Tear it off. Like a paper towel. And the other ester, we're going to convert to an acid group. Okay? So the result of all this will be a final carboxylic acid. Okay? So let me stop there, all right? Covered a lot. We'll come back to that on Monday, all right?